All right, you guys, so we're going to listen to an
Randall,
announcement.
please come to the main office. Kane and Randall, please come to the main office.
That's what I get for trying to make a video lecture in the middle of lunch. But anyway, we're going to take some notes on the types of elements that we just color-coded in the previous assignment. So if you haven't done that previous assignment yet, make sure you go back and do it, because our colorful periodic table, yours is going to be virtual, but our colorful periodic table here is going to help us identify what type of element something is and use that for various purposes like determining their properties and things like that. So we're going to start with a title, okay? So in your notes, wherever you're keeping your notes, types of elements. We're going to start with our metals. Okay, our metals. And we're going to make a key. So if you have colors, maybe pause the video, go get some markers, go get some color pencils, get some kind of coloring tool to help you with this. If you don't have colors, you might just write the word of the color instead of making yourself a key. But we're going to start with those elements that we colored in red over here in group 1 of our periodic table. So I'm going to make myself a little red box. All right. All of those red elements are in the group of alkali metals. Alkali metals. So we do separate our metals into several different categories. Alkali metals is our first one. And the reason why those are grouped together is because they have very similar properties that are different from other metals. So for example, these are very soft. If you have a pure alkali metal, you can cut it with a butter knife. It's very, very soft, okay? They're very shiny. All metals are shiny, but again, a pure alkali metal is going to be very shiny. They conduct electricity super well, okay? Conduct electricity super well. Another way to say that is they are excellent conductors of electricity. All metals are good conductors, but again, alkali metals taking a step further. Okay? And they are very reactive. So this is why we don't really use them when we're talking about conductivity, you know, electricity, power lines, wires, things like that. It's because they're very reactive. For example, they are explosive with water. So if you drop a chunk of an alkali metal into water, it's going to be an explosive reaction, very, very flammable. Okay, next we have our orange group 2 elements, our orange ones. I'm going to make my little orange box. That's not super visible, it's supposed to be orange, okay? Those ones are our alkaline earth metals. Alkaline earth metals, okay? And the alkaline earth metals have similar properties to each other, and they're sort of similar to the alkali metals, but we're not quite as soft, not quite as shiny, things like that. So they are soft. They are common in Earth's crust. Common in Earth's crust. They are conductive because they're metals. All metals are conductive. And somewhat reactive. Somewhat reactive. So again, we don't really want to use reactive metals as wire material because we're sending so much energy through those wires. We don't want the metal to react with anything because when it reacts, it's no longer that metal anymore. It's now part of a compound, and then it's not going to conduct anymore. So we want to use non-reactive metals like copper when we're making wires for our electronics and electrical conductivity. Okay, the next color, which is the majority of the metals, is going to be yellow. And I do not have a yellow marker, so I'm just going to draw a little box and I'm going to put a Y in it. and we'll say that's yellow, okay? All of these yellow elements on here are transition metals. Okay, transition metals. I guess I could underline each of these. Okay, transition metals, they still conduct electricity. So they're conductive because all metals are conductive. So just memorize that, then you won't even have to worry about it, okay? And they have a wide range of other properties. They have a wide range of other properties. I mean, for example, you could even go down to their color. Gold is part of our transition metals. Copper is part of our transition metals. Those two metals have very distinct colors compared to other metals. Most other metals are in the silvery gray color range, okay? Their reactivity is going to be different. Copper is less reactive than most of the metals, but gold is way less reactive. Silver is in between. Platinum is very non-reactive. And even their physical states. Mercury is a metal, but it's a liquid at room temperature. So we've got a really big range of properties in our transition metals. Okay. Now there is one more metal before we move on, and that is aluminum. And aluminum we colored pink. So find yourself a pink coloring tool. Okay, and it's aluminum. And aluminum, it's a metal, so it's conductive. Okay, you guys have worked with aluminum foil. You guys can maybe know its other properties. It's silver. It can be turned into foil. But it's on its own because it's right next to that stair-step line, but it's not a part of the other elements that are part of that stair-step line. So it is a metal. We know that it's a metal because we're used to working with it, but it's kind of in its own group because the elements below it are definitely part of the transition metals. And aluminum is not a transition metal. It only has one way to form a compound, and that's one difference compared to the transition metals. All of those can form multiple types of compounds. Okay. All right, so now we're going to move into metalloids. Okay, so we had metals. Now we're going to, that's the end of our metals. We're going to go into metalloids. Okay. And the metalloids are all the same color on the periodic table. They're gray. So I'm actually going to just put that color box right next to the title. I'm going to just do a hashed coloring because I don't have a gray marker either. But there's my metalloids. And metalloids are elements. Here's the definition. Elements that have, elements that have properties of metals and nonmetals. Elements that have properties of metals and nonmetals. So in other notes, we're going to learn that metalloids can be conductive under the right conditions, but they're not very conductive like the metals are, okay? They can be shiny, but they might have a different property of a non-metal. So for example, metals are shiny, but they bend when you hit them with a hammer, right? That's called malleable. Metalloids might be shiny, but they break when you hit them with a hammer. Like that would be called brittle. So it depends on the metalloid, but it's going to have a mixture of properties. It's not a mixture of elements. It's one element, but it has a mixture of properties from metals and non-metals. Okay? Okay, now that's the end of that section. We're going to go into nonmetals as our ending part of these notes. Okay, our nonmetals came in several colors here. We're going to start with blue. Okay, all right, blue is going to be our halogens. Okay, halogens have a couple of very similar properties. They are highly reactive nonmetals. Highly reactive nonmetals, okay? A couple of them are gases. They're super toxic because when you breathe them in, they react with your lungs, and that's what makes them pretty toxic, okay? But even the ones that are liquid or solid are very, very reactive. One of those is iodine. We put it on our cuts because it kills stuff, okay? So it's so reactive, it's toxic to living microorganisms. Okay, and they are colorful in their pure form. So you may or may not be aware that chlorine gas is green. Iodine is purple. It's a really dark purple, almost looks black. When you turn it into a gas, though, which takes not very much heat, it is a big, beautiful purple cloud of gas, okay? But when we dissolve iodine into a solution for putting on our cuts, it's kind of an orange color. So we've got lots of colorful elements in the halogens, okay? All right, next I want to do purple. I do have a purple. Okay, the elements that we color-coded purple are our noble gases. Noble gases. Now, we typically hear the word noble when we're talking about kings and queens and royal families. Those are the wealthy in medieval times would be called the nobility, right? The noble people. And they didn't associate with other people, other classes of people. So that's where this came from. Noble gases don't associate with other elements. In other words, they don't react with other elements. They are totally stable on their own, independent, and they don't ever react with other elements, okay? So they are non-reactive nonmetals. Non-reactive nonmetals. They have very stable atoms. Okay. On your planes and periodic table, those again are all located on the far right side of the periodic table. They're all gases, and one way that you can tell that on our planes and periodic table is their symbol is red. So all the red symbols on the periodic table are gases. They're not all noble gases, but all the red symbols are gases, and the ones that are on the far right are your noble gases, okay? Blue symbols are liquids on here, black symbols are solids, and the gray ones are man-made elements that we don't have enough of to really tell what physical state they are, but they would probably all end up being solid. Okay, then we have other nonmetals, which would be green. Here's my green. This is other nonmetals. There's 6 of them, and they just don't have a group to belong to, so they're just other nonmetals. Now remember, metals are conductive, nonmetals are non-conductive, so if you wanted to write a property, you could write non-conductive, but they just don't belong with anything group-wise. I mean, they're in a group with other elements that have similar properties if we change temperatures and stuff, but oxygen, sulfur, selenium are in the same group. They're going to have similar properties. Nitrogen, phosphorus, similar properties to each other. Carbon's kind of in a world of its own, sitting over here, but they are all nonmetals. And then our final one, if I didn't forget any, I don't think I did. I do not have a brown marker, but if I did, this would be brown, okay? And that would be hydrogen. And hydrogen is in a group of its own. It has totally unique properties compared to the rest of the periodic table, okay? It is a gas, it is a nonmetal, that's why we put it with the nonmetals here, okay? It is very reactive, but it's not a metal. It doesn't conduct electricity, it's not shiny, it's not solid, so it's not going to be part of the alkali metal group, so that's why we colored that one a different color up at the top of that group. It is the first element on the periodic table because of its atomic number, number 1, but it doesn't match the elements in its group like the rest of the elements in the periodic table can match the elements in their groups. So that is the end of the notes on types of elements, and this information will be super useful when you are doing your periodic table scavenger hunt. Thanks everybody, I'll see you in class.